So remember, when you're graphing an inequality, you're going to graph it exactly like you would a line. You're just going to decide what to do after that, because you do have to do some shading. So this first one is in slope-intercept form. So we're going to start at our y-intercept. That's positive 7 on the y-axis. Our slope was negative 5, so we go down 5 and over 1. So this was our second point. And then we decide if it's solid or dashed based on my greater than less than. This is or equal to, so I'm going to make this a solid line. So this should have been a solid line here. And then how do I shade? Well, my y is less than this line, so I'm going to go where my y is right here, and I'm going to shade down. Yeah, less than. So I will shade everything, well, not there, everything down here. All right. Questions on that one? Good. All right, let's look at the next one. So for the next one, it is not in slope-intercept form. So we are going to put it in slope-intercept form because that can affect our shading. So I'm going to subtract that over, and I get y is greater than negative 3x plus 4, which means I'm going to start at positive 4, and I'm going to go down 3 and over 1. Negative slope should give me, if I can get that to close, should give me something going down. So it's a real quick, easy check. If your slope is negative, it should be going down. Now this time it is greater than. So I am going to, again, I'm going to look for shading. It is greater than, so I go to my y, and it's everything on this side of the line. So that's where I'm going to shade everything on this side of the line. So we've been solving systems of equations, systems of linear equations. One way that we did it was we graphed, and where they cross on the coordinate plane is the answer. That's what answers it for those two. But if you have an inequality, it's not just one point. It's like half of the plane that your answer is, as you saw that we just did. And so when you have two inequalities, we're not seeing where the two lines cross. We're seeing where the two shades cross, all right? And so it is a full system of points that gives you your answer here. Look at this first one. They want us to solve the system of inequalities. Just like my systems of equations, I'm actually going to take this and I am going to put it in slope-intercept form. So for this first one, I'm going to move that 3x over to the other side, getting y is greater than negative 3x plus 4. And for this second one, I'm going to move the x over. That gives me negative y is less than or equal to negative x plus 8. My y, however, is not by itself yet. I have to divide by a negative 1, and I have to do that to all of them. So now I have y by itself. Because I divided by a negative, I'm going to need to flip that greater than less than sign, greater than or equal to. And then I'm going to do this process here. Negative divided by a negative is a positive, and then a negative there. So I need to make sure that I have completely gotten y by itself before I start graphing. And now I can graph them. I'm going to start with positive 4 for that one. My slope is negative 3, so I'm going to go down 1, 2, 3, and over 1. And then I'm going to connect those dots. And I'll tell you what I do with these, and you can do it. You can either use colored pencils, and you can use your shading, or you can shade really lightly to decide, because you're going to shade both of these, but your answer is only going to be where the shades cross. So if I shade this first one greater than, then I'm going to find my y-intercept and shade everything above it, which means it's everything on this side of the line right here. And so that's my shading for this first one. That's my shading for that one, right? Then I'm going to graph a second line. I'm going to graph this one right here. And so I'm going to go to negative 8, which is right here. And I am going to go up 1 over 1. And you can walk it if you want, but it's not as important as when you're looking for a specific point. So I'm going to decide, am I solid or am I dashed? And I actually didn't do that on that last one, so let me dash him real quick. He should be dashed, right? Should be a dashed line there. This next one should be solid. So he's or equal to, so I'm going to make him a solid line. And then I'm going to decide his shading. All right, so when I look at this one, this is greater than or equal to. So I have my line, and now I need to do my shading. My shading for this line is greater than or equal to. So if I look at this, here's my y value. Greater than is going to be on this side. And so if I were to shade him, it's really going to be everything on this side of the line. But in this case, you see how crazy that is? My answer is just the wedge where they cross. This is why I use lightly colored shading or colored pencils, because my answer here is actually just going to be this wedge right here. This is my actual answer. All right. And so you need to make sure that when you do these, you're very clear about what your answer is. I need to know that that's your answer. If you shade really lightly, you don't necessarily need to go back and erase. Some people do. You don't necessarily have to do that. Yours is going to be lighter because you're using pencil versus, you know, my iPad's makes it a little darker. I'll tell you the things that I'm looking for. I'm looking for your y-intercept and your slope to be correct and that it is dashed. I'm looking for y-intercept and slope and that it's solid. And then I'm looking for that you shaded where they cross over significantly so that I know that is your answer. Top of page 319, solving a system. Graph all inequalities on the same set of axes. Find the solution set where the shaded regions intersect. And then a lot of people want to know, can I check my answer? The answer, yes, you can. You can pick a point that is inside your shaded area and it should work for both of your systems. It will make it a true statement. First of all, they've given us 3. And the first 2 are just limiting. Like you don't actually have to graph those technically. X is greater than 0. So I find where X is 0. X is 0 all the way down my y-axis. So this right here is where X is 0. So which side of that line is going to be greater than that? Well, where do my X's get bigger? This side of the line. So it's going to keep you over here on this side of my graph. Then they want where y is greater than 0. Well, y equals 0 all the way down my x-axis, right? Greater than that would be above that line. So if I shaded this guy, it does that. Here's what x is greater than 0 and y is greater than 0 always does. it forces you to stay in the first quadrant. Okay, first quadrant. And so without even shading those two, these two tell me that I'm going to be in the first quadrant only. Okay, so you're welcome to shade those if you want, but you can also just go straight to your graph that it's asking about, which is this one right here. And you can graph him. Move your 2x over. You have negative y is greater than negative 2x plus 1. Divide by everything by negative 1. You get y, I flip that, is less than 2x minus 1. And I'm going to graph it. A negative 1 up to over 1. I am going to be dashed because it is just less than. So I'm going to dash this guy here. And then where is it less than? Well, I take this and it's everything on this side of the line, but what quadrant am I staying in? The first quadrant. So when I shade this, I need to shade everything on this side of the line in the first quadrant. Okay, because these two limiting factors kept me in the first quadrant. And if you shaded those, you would see that's where all three of them cross over, is in the first quadrant. To look at a graph that is given to us and then figure out what the two equations are. Okay, so you're just backing into it. I'm going to go with maybe this first one here that is a horizontal line. This is going to be a special case. This is going to be y equals a number, right? And so I'm just going to count 1, 2, 3, 4. That's negative 4. So the line itself is y equals negative 4, right? Where did they shade? Well, they shaded above this line, right? So normally I would have, for that red line, that line itself is y equals negative 4. But now I'm talking about an inequality. Did they shade above or below it? Above. So that indicates greater than. And does it include the line? Yes. So I need to add that little or equal to. That's my first equation, right? My next one. I'm going to go to my y-intercept. What is my y-intercept here? A positive 1. So I know that's my y-intercept. I need to figure out my slope. Is my slope going to be positive or negative?
Negative.
Negative. It's going down. So what I'm going to do is I'm going to find the next place where it crosses perfectly, right? And I'm going to see. I go down 1, 2, 3, and over 1. My slope is negative 3. Now I just need to figure out, is it above that line or below it? Well, here's my y. Did they shade amounts that were bigger than my y or smaller than my y? Smaller. So this guy is going to be less than. Did it include the line? It did. I need the or equal to. So my answer here would be these two inequalities. That's what makes up my graph right there.